好啦，咁事不宜遲，晏晝時間開始啦。再一次多謝今朝早有參與我哋上晝個 section 嘅training 啦，都係多謝大家。今朝早頭先Alex 咧有留佢個 contact 嘅，如果大家頭先抄唔切，但係對於今朝早嘅 training 嘅入邊，或者係點樣用佢哋公司Code Free Soft 入邊啲 tools， 你哋覺得有需要或者想再問多啲問題嘅，咁方便你哋都可以問我攞翻佢個 contact， 咁我可以再俾翻你哋。今朝早如果大家有啲聽漏咗，或者突然之間或者再重溫嘅話，我哋都有錄影嘅。咁我哋稍後時間會擺翻上去我哋 YouTube channel。咁 ready 咗之後咧，咁我哋都會喺我哋而家 WhatsApp group 入邊咧，咁我哋會同大家俾翻條 YouTube link 俾大家，到時大家可以再 recap 翻。好亦都今日晏晝好似有啲新嘅參加者嚟到加入咗啦。咁都想 recap 一下嘅。今次我哋個比賽咧，其實除咗比賽之外咧，都希望大家可以喺從中入邊可以學多啲嘢啦。吸收多一啲唔同嘅知識啦，或者知識啦，亦都希望大家可以真係透過利用到開放數據去為我哋嘅社會諗多啲嘅 solution， 幫到嚟緊嘅關愛隊啦，真係有一啲嘅 solution 落到地啦，亦都希望可以或者甚至可能唔緊要嘅，有陣時幫咗兩個人都會多咗嘅。咁再一次都恭喜晒咁多位入到嚟今次嘅決賽嘅培訓，咁你哋都好叻㗎。今朝雖然我係有講過小學生，今次好似好犀利喎，係因為我比較 shock 佢哋嗰個編排真係做得好好。咁但係其他嘅隊伍都一定係做得好先至能夠被選擇到入嚟嘅，咁都唔能夠抹殺到你哋自己嘅努力。咁亦都相信大家喺因為初賽嗰陣時其實都係講 POC 啦 ，proof of concept， 咁所以亦都相信其他中學、大專甚至乎公開組，你哋喺做有 prototype、有 website、有 apps 俾我哋睇嗰陣時咧，咁我絕對相信你哋一定都可以做得好出色嘅。咁但係都係記住我哋今朝講多嘅就係記住你哋個 target audience 係乜嘢。我哋都有講啦，成日都講就係話即係講笑咁講啦。我哋話嗱，你哋嚟做 presentation， 一定程度上你都當你都係一個 sales， 你嚟 sales 令到我哋去選擇你哋呢隊隊伍係值得高分，甚至乎亦值得去攞獎。咁所以你哋都要諗下，就係你哋 sell 緊嗰樣嘢，究竟係係咪？即係點樣可以令到你 sell 嘅嘢能夠得到最多人去接受你哋嗰個 solution 真係合適係去接納去用咧？重點亦都係之前都有講啦，就係話今年獲勝嘅參賽者，我哋係會盡可能會揾辦法幫你哋將你嘅 solution 落地，希望真係能夠喺唔同嘅地區度推廣。咁所以之前我哋就曾經搞咗 seminar 啦，今次亦都今個禮拜 training 啦，下個禮拜都有。咁稍後時間都有決賽，同埋我哋嚟緊頒獎禮都有 conference。咁希望中間大家譬如平時小 presentation 嘅，希望今次透過今次嘅比賽，我哋可以俾你哋可以有多啲機會做 present 啦。或者如果之前少接觸點樣去做 project management 嘅，今次都可以有多啲嘅接觸按 project management 係點樣做啦。咁如果之前譬如未試過用 cloud 嘅，都想接觸下咩叫 cloud 嘅technology 啊，有啲咩 solution 幫到大家咧？咁今日都請咗兩位專家，咁佢哋嚟緊就會同大家講解下喺 cloud solution 上邊，佢哋公司可以提供到啲咩嘅solution 俾大家，去幫助你哋去建立你哋嚟緊嘅 proposal 啦。咁而家有請我今日晏晝嘅 speaker Sean 同埋 Carl。
Hello， hi 大家好，我叫 Sean， 我哋係來自Deployify， 係一個做 machine learning operations 嘅公司。咁我哋今日喺呢度要介紹嘅嘢咧，就係要講下 machine learning 係乜嘢啦。你可以用 machine learning 做到嘅嘢係乜嘢啦。 同埋喺cloud 上面可以做到嘅 machine learning 嘅感覺嘅 experience 係點樣㗎啦。So I think a lot of the workshop that I'm going to talk about is going to be mainly in English, but I'll try to use a little bit of Cantonese here and there. 少少廣東話，因為我廣東話唔係幾好。I'm personally from Malaysia, so 我可以講嘅廣東話只係到一個 OK 嘅程度啫。Right, so let's get into this. Turn this on. Right, so it's gonna take like 2 minutes to turn that on. Yeah. So I'm going to do it like this. It's a workshop. It's going to be like maybe 2-3 hours long. So we will take like maybe 10-minute breaks every 15 minutes. So don't worry that I hope not to make this too boring for you. I think this is clear enough, right? All right. Okay, so let's get started. Right, so my name is Sean. We're from Deployify, and the two of us have been building this company for about 2.5 years, 3 years long. We've been working on the cloud for machine learning. We are able to provide, we've engineered a lot of interesting cloud solutions in the last 2-3 years. So whatever that you're going to see later is everything that we've built so far. We've put a lot of, frankly speaking, we've put a lot of love into the product that we've made, and we hope that you will be able to appreciate our approach and try it out yourself later. So the both of us are from HKU. We did engineering. So Utkarsh did computer science. I actually did mechanical engineering, but I did a minor in computer science. And for me, I actually just recently graduated from HKU in June this year, and I hope to make this to continue our work here. So a little bit of what we're going to talk about today. I'm going to introduce what is machine learning. So machine learning in a very technical perspective. I'm going to talk about why we use the cloud for machine learning. I will also talk about how machine learning on the cloud works, what are the necessary things, what are the components, how they come together to allow machine learning to work. And I'll then introduce Deployify, what are the features and products we have, and what you can try to use throughout your hackathon. All of that is going to be free because we're sponsoring cloud computing for machine learning for the event. And finally, I will show a demonstration of building an actual machine learning model to accomplish a certain task. Okay? So the workshop is going to be technical, all right? But don't be afraid of asking questions. If you see some certain things that you really want to know more about, feel free to just raise your hand and interrupt me, and I'll try to just explain in a little bit more detail if you like, okay? So before I continue, any questions first? Okay, right. Okay, let's jump into machine learning. Now, in This is the definition that I would give. There are a lot of other definitions, but how I would define it is as a tool that can do complicated tasks. Okay, so for example, when you look at certain AI things, when other people talk about AI, they can do amazing things, right? Like recently you have ChatGPT. ChatGPT 就係你可以打 prompt 入去 and then 去 generate 個 response 出嚟㗎嘛。所以呢啲都係 AI 都係 machine learning 嘅嘢嚟嘅。咁最新嘅嘢就係呢啲 ChatGPT 啦。咁比較舊少少嘅 AI 嘅嘢咧，就係有啲 model 係可以 recognize object recognition。就比如話你俾佢一個 picture of a dog，it's able to recognize that it's a dog。Or if you give a picture of a cat, it's able to recognize it as a cat, and so on and so forth. So machine learning is basically something that allows you to do very complicated things compared to traditional software like a Google form, which only takes a form. That's not machine learning, that's not AI at all. So as a simple example, you can build a machine learning model that can recognize pictures, that can differentiate between a picture of a dog or a picture of a cat. So if you feed a picture like this, it's able to tell you that it's a dog. The model is able to tell you it's a dog with AI. Or if you give it a cat, it's going to tell you that it's a cat. So how do we build this model? I can give you a little bit of a brief process as to how this is accomplished. The first step in modern machine learning practice is to collect and label data. 我相信好多你在座嘅各位都有聽過，data 係好重要嘅，係第一步 ，right? To AI to machine learning. That is true. That is the modern approach. The reason for this is because you want to create something, machine learning model, that is able to recognize patterns out of that data. Which means if you have more data, that means your pattern recognition algorithm, that logic, is able to perform better. So that's why the more data you have, the better your model performs in general. So for an ML model that recognizes the picture between a dog and a picture of a cat, what you need to have a lot of pictures of dogs and also a lot of pictures of cats, and you need to be able to label which pictures are dogs and which pictures are cats. Once you have a lot of pictures, like let's say at least maybe a few thousand, I would say, you can design and train a model. So in machine learning, there are all sorts of different kinds of models. And for a model that's able to recognize between a cat or a dog, we would use something called a CNN. So CNN is an abbreviation for convolutional neural network. Okay, I don't know if some of you have done any machine learning before, you might have recognized this. So the idea is that you take a picture of the input of a cat or a dog, and you would slice the picture into many small little squares. Technically, you can just take the pixels of the image, okay? And then you would run a CNN network. What that means is you would try to find correlations, mathematical correlations between each pixel, and try to figure out some kind of relation between the picture and what you're trying to predict, which is whether it's a cat at a 95% or a dog at 5%. So the model's job is to dissect the image and run it through a bunch of mathematical correlations, a bunch of linear equations, like ax plus by equals plus cz, something like that, to come up with a final output like that. So once you have a model, generally speaking, you want to bring it to an application, and for your hackathon, you want to be able to, as what Eddie has mentioned, you want to bring it down to the ground, you want to let users try or something like that. One way to do this is that you can take your model and put it behind a web application. So what that means is, let's say if you have a picture of a dog, you can upload it to a website, and then the website will run the model by sending it. The website will send the picture to the model. The model will analyze it and then come up with the response as an output, something like that. So generally speaking, in machine learning, the modern way to approach this is step one, you want to collect a lot of data. Step 2, you use that data to design and train your model to do pattern recognition, basically. And then step 3, you can create an application out of that model. And generally speaking, you can continuously improve your model by collecting more data and retraining your model over and over again. Okay? So these are no matter what AI you're trying to do, if it's ChatGPT or which are called LLMs, large language models, or basic object recognition models like this, or it could be some foot traffic prediction model or anything, right? Anything that involves AI or pattern recognition out of a lot of data. These 3 steps are the basic components of doing all of those things. Collect data, design and train model, and create an application. Any questions so far? Am I going too fast, actually? No, am I going too slow? Okay. Is this too technical or too difficult? Please let me know. I'll try to dumb it down. Okay. All right. So that was all about machine learning. Okay. Now, how do we do this on the cloud? Generally speaking, let's say if you want to do it on your computer, okay, there are a few restrictions usually. You can only work on models that are small, okay? Like usually models are actually, machine learning at the end of the day is a piece of software. Okay, it's like when you download a Google Chrome browser, it will take up like 1 gigabyte of your space, right? So a machine learning model is also a piece of software. It takes up space. So a simple ML model could be like 500 megabytes in size. A very big ML model, something like what ChatGPT is running on, could be tens or hundreds of gigabytes in size. Okay, it could be up to a terabyte. I'm actually not sure. So, but if you do machine learning on your own computer, generally speaking, your model size needs to be small because your computer doesn't have unlimited storage space. Like my computer only has 500 gigabytes of space. I can't run a model that's more than 20 or 30 gigabytes. I'll just run out of space already because I have other things on my computer, right? Now, secondly, machine learning models are very expensive to run because they need to do a lot of mathematics, a lot of linear equations like ax plus by plus cz, that kind of stuff, okay? And it's actually a lot of these kind of equations. And generally speaking, you would use a GPU, like an NVIDIA GPU, to do these matrix calculations. And if you use it on your own computer, again, it's going to be small scale, like maybe your computer comes with NVIDIA GPUs, then you can use it for machine learning. Which means doing machine learning on your own computer is generally a little bit slower, and you can't really use a lot of disk space. Now, this is where the cloud comes in, where Deployify is trying to advocate, is to do machine learning on the cloud. Why the cloud is useful is because, again, the cloud enables very large models. Like those ChatGPT things, those large language models that you see, they all run on the cloud to be on a large scale. So on the cloud, you can use a lot of GPUs at the same time. You're able to do large-scale GPU training. Like for example, there are these GPU hardware called A100, H100s, very fancy names, very expensive GPUs. They're like thousands, 5,000, 10,000 US dollars each. Okay, you wouldn't want to buy these GPUs yourself. You can, but it's usually better to just use these GPUs in data centers. So these are provided by Google, these are provided by Microsoft, these are provided by AWS, they're provided by Baidu Cloud, Tencent Cloud, Alibaba Cloud as well, perhaps, yeah. So which means if you do machine learning on the cloud, you're going to be able to run models faster, and also this storage on the cloud is basically unlimited. You can have however small model you like or however big model you like. So cloud for ML. There are these tools that I just mentioned briefly. You can do machine learning on the cloud, on AWS, on Azure, on Google Cloud. I'm not sure if some of you have recognized this. You can do it on Kaggle, you can do it on Google Colab. and also Deployify is a provider of cloud solutions for machine learning as well. Right, so the reality is, what I just showed you for machine learning, collect data, and then you design train model, and then you try to create an application out of it. It seems very simple, 3 steps, right? The reality is actually this, it's very, very complicated, okay? Even from the data preparation and analysis stage, you have a lot of tools that you might need to use to be able to analyze your data properly, to somehow come up with a relation. You want to try to understand what the data means. 其實你如果做一個 ML model 嘅話，你要睇你自己嘅 data，你要 gain some insights out of it, and you need tools to do that, and there are a lot of tools that allow you to do that. So from there, we need to kind of like do data preparation, feature engineering. I won't go into the details, but it's, well, things that data scientist people do, okay? And then from data, you can design and train a model with all sorts of tools out there. There's some TensorFlow, PyTorch, Scikit-learn, Apache Spark, and we run it on a Jupyter notebook, okay? With ML models, AI models, so as to say, there's a significant component called security, called safety, right? You don't want your AI model to do crazy things, right? Like you don't want ChatGPT to spit out like racist comments and stuff like that. So this is where model review, model governance, safety comes in as well. It's very important things. And then once you have a model, you want to let your users use. There's a whole infrastructure, a whole lot of software that needs to be written to be able to serve your users. And all of this stuff needs cloud infrastructure to run. And infrastructure management is also another problem for data scientists. So in reality, machine learning, data scientist people deal with this, okay? Now, what Deployify is trying to do is to provide few things that can help make that process a little bit easier. One thing is we provide data storage on the cloud. So what that means is you can store data like thousands or tens of thousands of images on the cloud, and then you want to run your model training on the cloud as well. So Deployify is able to like create these, it's a little bit like Google Drive. Okay, everyone uses Google Drive or like Baidu Cloud Drive, some kind of cloud drive, right? Or OneDrive, right? So data storage on the cloud is basically like Google, creating these Google Drives, but for machine learning, okay? And then we want to be able to access this data easily. And the approach that we've taken is to create training servers. So these are like, training servers are like computers, your own computers, but they're in the data center, okay? So what you can do is, you can connect to these training servers and basically write code this or analyze your own data. So this is, for example, some games.csv. CSV stands for comma separated vectors, values, right? Yeah, values. So CSV is like Excel files, so you can table data. So training servers at Deployify, we're able to import the data sets. What it means is that whatever data that you put on the cloud, okay, through Deployify, you're going to be able to see that same data from the training servers as well, okay? And here's the great thing about storing data on the cloud. There's no size limit. You can store however large file you like, virtually. You can store however many files you like. So machine learning is something that benefits from using a lot of data. So if you have a lot of data, you put it on the cloud, and then you'll be able to access it easily from a training server like that, without having to download it explicitly. On the training servers, the main thing you do is it's a training server. You want to do model training. So you design your model, you write code, you do Jupyter notebook stuff inside of it. So for example, there's a little bit of some NLTK stuff. So it's a language model sort of thing. And connecting to a training server from Deployify is very easy. If you already use VS Code, you can download our Deployify plugin and be able to just connect to your training server easily like that. I'll show you a demo later how that goes, okay? So let's say you have a model that's been trained, you want to send it to your users to use, like you want to create a web application. generally speaking, you start with a model like this, and you have to add a little bit more stuff. So there are tools, there are frameworks called Gradio, Fast API, and Meteorite. They'll be able to basically give a web UI, because a model is just a bunch of math, okay, a bunch of linear equations. You can't really see it. You can wrap it around a UI library, and so that you can give it to your user to interact with. We put it inside of a Docker container. I won't go into the details, but basically you take all of this stuff and you put it on the cloud again, so that you can get some kind of a website like abc.com, and then you'll be able to play with your model from there. Okay, that's all the basic, not basic, all of the complicated, boring stuff out of the way. I think most of the workshop I'll spend a lot more time on doing demonstrations, okay? But up to this point, is there anything that you're not sure of? Anything about machine learning that you'd like to ask before we jump into demos? Yes?
Go back to your slides to when you talk about like actual, like the
Yeah, sure.
This one. So basically, it's going through the cycle every time you
Something like that, yes. So let's say if you want to create a new model that solves a particular problem, okay. These are sort of the core steps that data scientist people will have to go through. Okay, it's not like one person doing all of this. Okay, it could be a whole team doing all of it, or you could have sub-teams within the data science team that will focus on feature engineering. You may have sub-teams that are focused on model review and governance, caring about safety, model safety. You could have sub-teams that care about inferencing, serving the model to the users. Usually it's something like that. It's not one person doing all of this. But in general, in the real world, in production scale, this is the kind of stuff that they need to go through. Yeah.
So, usually you can, like, the more project, you can automate this with the cloud, like some of you do it, right? Or it requires just to do stuff manually.
Right, so I'll put it like this. Cloud computing is just it's the basic part, okay? Setting up all of this stuff, it's actually more abstract than just cloud computing, okay? There are tools that allow you to run these steps automatically, okay? But not all of it, because I think a lot of the time you still require a human to monitor the process. Okay, to actually design the process, because sometimes for each model you may require slightly different requirements for each step. Okay, so like for example, a ChatGPT model, okay, is very different from an object recognition model, like the dog and cat picture recognition model that I talked about. They're very different. Okay. Because let's say one input, it requires text prompts, right? And then it spits out a response as a bunch of text as well. But an object recognition model expects a picture, an image, and then it spits out basically a probability of whether this is a dog or this is a cat. From the model themselves, they're already quite different. They're both machine learning models, but they do different things. So because they do different things, some of these steps would already be quite customized for each model. So you need people to be able to understand the model, design each of these steps properly, and go through with it. Yeah.
So it's basically you modify every time you change a different model.
Pretty much, yes, pretty much.
So this is just a general diagram of how it works.
Yes, general diagram for almost any ML model, basically. These steps are pretty much necessary. If anything, right at this moment, there's a real focus on model review and governance because ChatGPT exists. There's a lot of safety problems, okay? Like you really don't want your model to spit out racist slurs, okay? Or you ask it violence, war stuff, protest, or whatever, things that are not legal, okay? which is why there's a lot more focus on this area, specifically for ChatGPT kind of models. So there's still a lot of development, exciting development in this whole area, in all of machine learning. Yeah. Any other questions? Right. I didn't expect to go through this part that quickly, so we're just going to spend more time on demos, I suppose. Right. We'll take a break at around 3 something, so I think we can do the basic part first. Okay, step 1. Does everybody have a GitHub account? Because what I'm about to show you is to sign up on our platform, you would need a GitHub account. So GitHub is basically, well, it's a software tool that basically all software engineers use. If you do machine learning, you're basically also doing software. So if you don't have a GitHub account already, if you don't know what GitHub is, you would need to, in order to be on our platform, you would need to create an account of your own. All you need is just, I think, just an email, which I think you can kind of like sign up from here. Wow, did we change this experience? It never used to look like that. Something like this.
Sean, can you show the website again, please?
Okay.
Yeah.
This.
Yeah.
Yeah. Right, okay, so that's a good question. I should have talked about it first. So I'm just going to briefly go through what we're going to do later. First of all, create a GitHub account. And then using your GitHub account, you can sign up to Deployify, which is the platform that we have. And and the tool that we're going to show you is all on Deployify. Okay. Now, the benefit to doing this is that you'll be able to join as a member to our Deployify workspace specifically for this hackathon. Okay. And all of the resources you create, all of the things that you want to use in this workspace is all going to be free because we're sponsoring it. Okay? Right. I suppose I could introduce GitHub a little bit for those who don't already know. It's basically a platform for you to store your code, because what we're doing here is actually a bunch of programming stuff. Okay, and program is just where you write code. Right? So GitHub is a place where you can store your code basically on the cloud. All right. They're one of the first people who created this tool to be able to store code on the cloud and be able to retrieve it easily. So, for example, I have something like this. So on GitHub, code is stored as a bunch of repositories, and inside each repository you can basically browse like a file browser. So I have something like 2023, and then I have a bunch of like different programs, different files. For example, this is something that I've been writing for Rust. Okay, it's Rust programming. And GitHub basically allows you to like put all of this stuff on websites, something like that. Okay. And then why we use GitHub through Deployify is because I want you to kind of like sign up to Deployify through GitHub. It's a little bit like when you sign up for certain websites out there, you can use your Google account to sign up, right? So for programmers, for software programmers, machine learning scientists included, we basically use GitHub as our authentication to another separate platform. Most of them do it like this. Yeah, so that's sort of like this is why it is the first step to be able to use Deployify in the first place.
So is anybody having a problem signing up? I can come to your seat. Everybody has a GitHub account. Anybody who has a GitHub account?
有冇人有問題？有問題舉手。有冇問題
？Just as a show of hands, who knows about GitHub already? Not too bad. Not too bad. So I assume that you guys have your own GitHub account already, right? Yeah, then you can just use that. Yeah, you shouldn't need to sign up for another one. Okay. But for the rest of you, I'm not forcing you to do this. But if you're keen on taking this to the next step, keen on learning how machine learning feels like on the cloud, keen on getting on our platform, then please give it a try. So for those who already have a GitHub account, if you'd like to do me a favor, please help people around you to sign up if they are trying to. Okay, that would be really great. That would really help me out here. So if you see this on your web browser already, yeah, take a small break. We're gonna wait for everyone else who wants to try this to get to this point as well, and then we'll move on together. All right. I hope everyone is back. I'm just gonna continue. So I think most of you who want to try this, you should have a GitHub account already. And then the next step is to get onto our platform. And we would like you to go to this website, deploy.ai, which reads Deployify, /sign up. And over there, you should sign up for your own Deployify account. So it will be a little bit like this. So you should see something like this. And then all you have to do is just continue with GitHub. Okay? So open this page on a different tab, browser tab, and then go to deploy.ai/sign up. Deploy.ai/sign up. So let me just very quickly sign up for a new account. Okay, I didn't know it was that difficult.
嗱，呢一個咧就係一個好好嘅 example 咧，就係千祈唔好做 lifetime demonstration， 10次有8，即係好似咁樣10次有9次半都炒嘅，就係咁啦。永遠都遇到一啲不能預算嘅問題。唔識數。做乜㗎？Yay!
Thank you so much. Yeah, when I signed up for my GitHub account back in 2016, it was definitely not like this. It was simpler. Okay, so the idea is once you have your GitHub account, you could go sign up and then continue with GitHub. Then you should just ask for your, what was my username? Something like that. And then Deployify is going to ask you for permission to basically verify for your account, to authorize Deployify. And then you should see something like this before signing up. So the username that you can put in here, you can just keep it the same as your GitHub username, okay? And then first name and last name, you just put your own names like that. And then for the email, try to use the same one as you did for your GitHub account. Which I will use. Okay, right, so the next step, you might see this, okay, is to install our tool, because what we're providing at Deployify is a developer tool, so we have a CLI, it's a command line tool, that you might need to launch a terminal or a command prompt, so terminal on macOS or Linux, or a command prompt on Windows. So what you will do is something like this. Okay, the terminal. And then for macOS, you would need something called Homebrew. Okay, so you can search for Homebrew, and then go to brew.sh. Okay, and then install Homebrew by running this command. So you can just copy and sort of paste and run it here.
We missed that step already.
Which step exactly?
We just picked we missed the instruction.
If you miss these instructions, that's okay. That's okay. All right, it's okay. You don't, for today, you don't really need to use the CLI. Okay, but I would demonstrate using the CLI. Okay, so it's okay to just click next. But if you're already a software programmer who already uses Homebrew, I highly recommend you to try this. Okay. And for Windows, there's a bit of a mistake here that I need to fix later. For the first command, it's scoop bucket add deploy file, and then you copy this link afterwards. So basically, scoop bucket add deploy file, and then you put the rest of the URL. Yeah. So the missing part. Yeah, but we forgot to add. Yeah. For this is for Windows, by the way. All right. So basically, for different platforms, you would run these different commands to install a CLI. We basically use our CLI to interact with our platform, to be able to upload data sets, download data sets, and do some other cool stuff. So I try not to be hung up on too long on just this step. I just want to show you how the overall platform looks like. So I'm just going to hit next for now. Though we can show you how to install CLI in a bit more detail if you're interested. Now, the next step is to add a cloud provider credentials. For today, I will skip this part. Okay, just scroll down and start using deploy file. Okay. All right, so what you see here is your own personal workspace. Okay, it's like your own Google Drive. All right, you'll be able to find other people's workspaces as well if you join other teams. Okay, we will actually join a common workspace together called HKtag 2023. I will show it later. And in that workspace, you'll be able to use everything in deploy file for free. So let's try to do that. So actually, before I move on, is everybody able to see this? Those who are trying, please.
Anybody not on this yet? Any trouble?
有冇問題？有問題舉手。
So once again, the sign-up link is here. Once you have a GitHub account, open a new browser tab and go to this and do some work. You can just keep hitting next. Any questions from anyone? So I think we'll just wait for another 1 or 2 minutes and then we'll just move on. Okay, so I think I can just continue, right? No one has a problem with me doing that. I can continue? Alright. Okay, so once you have signed up to Deployify, this is again your own personal workspace, your own container, so as you say. We need to join another container, another workspace, for all of us to be together. Alright. So to do that, we go to the next slide, right? So you need to fill out a form. The form website is here, tally.so/r/blah blah blah. So for your convenience, if you want to use a QR code for the same website, you can do that instead. Okay, so I'm going to go through a process with you as well. I'm just going to copy this and paste it. So it's just a simple form to get to know you, all right? Make sure to just try to put this in. And you want to make sure that your email address is the same one you use for Deployify, ideally for GitHub as well. Okay. So it's up to you whether you would like to receive product updates from us. We might or might not send you emails. Not every day, not every week, but just sometimes, okay? You won't spam you. So once you submit this form, okay, you should be able to, you should receive an email from us to join the HKtag workspace. Okay, this is pretty cool. I can see that a lot of people have submitted the form. If you put in your email correctly, you should be able to, after submitting the form, you should be able to find an email like this that would invite you to join the HKtag 2023 workspace. Okay? Sorry. So the form website is here. This is a little bit of a live debugging right here, just looking at the backend, so we're making sure that you're receiving the emails. For example, I think one of you, ongun410@gmail.com, hopefully you've received the email. Okay. So hopefully you should be receiving an email that looks like this for you to join the workspace. And then all you have to do is to hit accept the invitation. Alright. If this doesn't work for you, there's a link down here that you can copy and put it in your web browser, and you should be able to join the team. Okay, actually a lot of you have managed to join, right? Maybe some of you are not able to do it. Anyone who's not able to do it right now? Access denied? Could you come to the front? I could help you debug it.
Click on this. I click on that, get this.
Okay, one thing to be very important is that the form that you fill in this form that you fill in, okay, needs to be the same email as the email you use to sign up for Deployify. Okay, so basically, this email here, please make sure that it's the same as the one you use for Deployify. Okay? You remember when you sign up for Deployify, you need to put in the email. Make sure that this email and that email are the same. Okay? If you think they're not the same, you can try to fill in the same form again. That's okay. Alright, just try to fill in the same form again with that same email. FYI, where you can find your email is, I think, here. Go to workspace settings, and then your email should be this one. Okay? Make sure that this email is the same as this email. Okay? Anyone has problems that I need to come over to help?
Anybody else getting access to this?
Alright, so for the rest of you who managed to join the workspace, you should be able to find something new here, okay? If you go back to Deployify's dashboard. First of all, you have your personal workspace. My username is called 98Sean98, and I have a bunch of teams that I'm part of. So you should see HKtag 2023. Click onto it, and then you should be able to see something like this. Okay, so are most of you here, or is anyone still very stuck? Okay, okay. But is it possible if I just move on a little bit? Yeah. Okay, so now we can finally start. The onboarding part was not that smooth, arguably. Okay, there's a bunch of emails, there's a bunch of GitHub, Deployify sign up, all that crazy stuff. But we're done with that. Now we can start doing some real interesting stuff. Okay. So first of all, on Deployify, we have a concept called projects. So we have a machine learning project, okay? And for this hackathon, I know that all of you here are organized into teams, right? I think one team has like what, 3 people, 4 people, something like that. Okay. So for each team, please create your own project. All right. Everyone here is using the same workspace called HKtag 2023. So technically, you can see other people's projects. Okay. But please don't fool around too much. So for example, I've created an example team, and this is the one that I'm going to use for a demo later. But the idea is that you want to create a new project like this. Arguably, that is not supposed to. Okay, a little bit of a hiccup in our backend server right now, but I think it should be back now. Okay, right. So I think people are creating projects already. I think hopefully this is who created this? Okay, good job. So the idea is for each team, please create just one project. All right, one team, one project. And then everything that you want to do on Deployify, you put it inside of this one project. Okay? Wow, there's a lot of projects already. So the spinning circle means that the project is being created. And once it's done, it should look like this, no more spinning circles. And you should be able to go into the project and see a bunch of stuff. Okay. So I was actually going to demo how you create a project, but I think most of you already figured it out. It's pretty straightforward. You just give it a name and choose a cloud profile for us. We just have to leave it as the default, just this one, and it's fine. Okay. And FYI, for those who know what Azure is, we're actually doing all of this stuff on Azure Cloud. Okay. Alright, so we don't really need to wait for all of these projects to be created. We can just continue from here and can finally start to do something interesting. Okay. Now I'm gonna demo a small little project that I've worked on in the last 2 days using the data set that was being provided by the hackathon organizers. So particularly, I've looked at air quality data. Okay, so this is data that's coming from the Environmental Protections Department, actually. So I can bring that up a little bit. Okay, so I believe that is here. This is the reference data set for the Open Data Hackathon, which is everyone that is in. It's the reason why we're all here. From the reference data set, there's a bunch of interesting things that are here, and I just basically picked off the ones that are on top. There's one for air quality data, okay? And there's one for Hong Kong weather reports, weather data. So I've taken these two data sets to do something interesting with them. I wanted to predict the quality of air given the weather of the day and given the day and time of the day. So for example, in the data set itself, we have on 1st of January 2020, hour 1 refers to, I believe it's 12 a.m. Okay. You have SO2, which is sulfur dioxide, NOx is nitrogen oxides, and CO, carbon monoxide. These are pollutants, and the numbers refer to how much there is of each category in the air at a certain time. So on the right hand side, we have daily weather data. So this is actually weather data that's taken at Hong Kong Observatory, HKO, but it's separated by days. So on 1st of January, maximum temperature, and minimum relative humidity. So what I've done is that I combine these two data sets together to predict NOx, to predict this column. Basically, let's say given max temperature, mean temperature, and all that, given the time of the day, I want to be able to predict how much NOx is there in the air without actually measuring it. So this is pretty interesting because if we look at just on one day, 1st of January 2020, NOx values actually kind of fluctuate a lot. So at the lowest, you have like 30, 40-ish. At the highest, you have like 130, 140-ish. Now, the reason for this is quite simple. NOx is produced by mainly vehicles, cars, okay? So, which means when cars are running, they produce a lot of NOx pollutant. So when cars are not running, there isn't as much NOx in the air. So, which is why if you look at this data, in the middle of the night, like 1 a.m. to like 7 a.m., NOx is very low. And then during the day, NOx values can be basically more than 4 times of its lowest values. So it's very interesting to analyze this data and basically create a machine learning model that can predict how much NOx is there in the air. Okay? Right. So I'm going to go through the data set a little bit. I think we can. I think I'll demo the part where how we download this data. Okay. So basically, I went to this website, reference datasets for Open Data Hackathon. There's a bunch of air quality data that you can just download straight up like that. And Hong Kong weather reports, you can just download something like that. But they're not immediately usable. You usually have to pre-process it. And I'll show you later what I did to pre-process the data. But basically, once they are downloaded, they kind of look like this. I believe it's this one. In Excel format. And it's a very large piece of data, so I'm actually not able to like open it properly. So I'm just going to do this. This is in Excel, so I think I might have done this. So we go to the Environmental Protection Department, I'm not very good at this. So basically the idea is you can choose to download specific air quality data for different locations. Okay, you can choose to have like Central, Causeway Bay, or Sharkin or whatever. And then you can choose whichever data you like. So for the ML model that I made yesterday, I was only focusing on nitrogen dioxide. Okay, because it has a lot of fluctuations. It's easier to see the difference. Okay, to predict as well. Particularly, I only looked at Mongkok, okay, because I think HKO, Hong Kong Observatory, is in Tsim Sha Tsui, 最近嘅就係旺角咯. So I just chose this to be referenced with each other from the weather data. And then you can take on the hourly data and then just basically take whichever time and date you like. Okay. So for the data set I used, it was basically just from 2020 to January 2020 to February 2023. So it's about 3 years worth of data, a bit more than 3 years. Yeah. So the data kind of looks like this. As I mentioned, for North Holland is focusing on this part. And then for daily weather, it has like all this stuff. Now for daily weather, it can be obtained from here as well. Hong Kong weather reports. Okay. And to download it, there's a bunch of instructions actually. There's an HKO Open Data API documentation. If you want to use weather data, I think this is a very good place to start to grab your own data sets. You will need to perhaps write some simple programs to make some web requests to be able to download stuff and organize all of that stuff. I can show you what I did later exactly to do this. But that's the idea. To be able to start with machine learning, you need to have data, and these are the places that you can start from for this, particularly for this hackathon, fitting to your team, smart living, something like that. Okay. All right. So I won't delve on this too long, but the data set that I made. So,
so I think there are some people that are still having trouble with the form. So Actually, our quota for sending emails has expired, so we're not able to send emails, right? So I would suggest that if anybody is still not on the team, on the workspace for to clarify, just come to me and I'll manually add your username to the team.
Right. So going back to the data sets, right? You can download most of what you probably need here. There's even Hong Kong average maximum minimum temperatures. Hopefully they're in CSV files or Excel files that you can work with easily already. Exchange rate, Wi-Fi information. There are a lot of interesting things here. Okay. So if there's a particular area in your hackathon that you want to make use of machine learning, that you want to make use of data, this is a good place to start. Another good place to start is CSDI. Okay. CSDI, Common Spatial Data Infrastructure. So this is a platform where you can download a lot of geospatial tag information. So for example, you can search for something related to education. Kind of like find out where are the higher education institutions. Not that interesting, but facilities information, list of through train schools. Enrollment. So something like this, student enrollment in secondary day schools by district and grade. So you can maybe look at this data set and figure out something interesting related to this topic. You can also preview the data first from CFDI. Yeah, so something like this. So this is the district for Sati. And then you can find out, oh, so in secondary 1, how many students are there? Secondary 5, how many students are there? So there's a lot of interesting data sets that are publicly available for you, all provided by Hong Kong government, okay, by the Statistics Bureau. That you can sort of find online. It's all there. Okay, so going back to data set processing, let's going back to machine learning. I'll going back to the example that I'm going to show you. Here's what I'm going to do. So let's say you have some data set that you downloaded already and you want to use it in your project. I will go back to example team here. Okay. You can create a new data set. Right. So over here, creating data set. Just put in name, anything you like. Again, keep the cloud profile the same, just keep using the default. And it's going to take maybe 1 or 2 minutes to create the actual data set, and then you'll be able to start using it. Okay, so all right. So let's say there are some files that you want to upload to your data set. Once this has been deployed properly, what this data set allows you to do is that we can upload some files and then start using it later. So for this example, I've already created this hourly CSV, process data, and some weather data. Okay. So uploading this data set requires using our CLI. Okay. And I'm not going to force you to try to follow what I do, okay? But I'm just going to give you an idea of what it feels like, okay? But the idea is, let's say you have some of these files. I'm just going to okay. I'm using a terminal here. Okay, so please bear with me. Let's say I have some of these files that I want to upload, okay, to the data set. I'm going to start using it here. It requires using some of the deploy file commands. So this is where the CLI command line tool comes in. And to install the command line tool, it's there in our documentation. So first of all, go to docs.deploy.ai. Okay. Don't worry, there are a lot of these links that I might show you, but I'll put them all nicely in the Notion page, on a public Notion page, and then you'll be able to find everything that you need there afterwards. So docs.deploy.ai, this basically leads to our documentation site. And from here, you'll be able to find how to install the CLI. Just go on CLI installation. And then for macOS, you follow these instructions. For Windows, for Ubuntu, Debian, Linux, and so on and so forth. Okay. All right, so going back to this, actually, before I continue rambling on and on, just a show of hands. Who knows how to use the terminal or the command prompt? Terminal, command prompt, anyone? You're okay, good. Thank you, sir. Because cloud at the end of the day, it's a very developer tool sort of thing. So there's really no other way to interact with cloud without doing it through the CLI. So, but if you're interested in doing any form of programming, it's an important thing to learn how to use the terminal, how to use the command prompt. There are these basic commands that I can showcase a little bit, like, for example, PWD, that means print working directory. This tells you where your terminal is in your file system. So I have a bunch of, this is my username, I have some documents, I have some programming stuff, I have deploy file. Each of these are like folders, okay? So I'm inside of a very deep folder called dataset, something like that, okay? There's ls, which basically lists all of the files that you have in this folder, okay? There's ls fact la, which basically tells you more information about each file in your folder, so on and so forth. So terminal basically lets you do these things, and the deploy file CLI basically works here. Deploy file, dataset, this and that. So the CLI, we have a bunch of things that you can do with the CLI. You can log in with the CLI, you can manage your projects, okay? you can manage your data sets and stuff like that. Okay? And I'm just going to quickly showcase just some of these things that you can try to use, but it's no worries, okay? I will showcase a possible way to do this without the CLI. I think there's a way to do this without the CLI, to work with your data sets.
I think we'll just like 5 minutes of interactive Q&A because I know there's been a little bit of chaos. So I don't have any prizes for anyone. So don't expect an award at the end of this if you get it right. But I'd love to see who's proactive. All right. So well, we're talking about machine learning. So in the sort of context of machine learning, what is a data set for? Why do we need a data set? Can anybody explain? Yes.
So like we need data sets in order to feed the machine.
Yes, but what does it do? Like why do you need to feed the machine with data?
It acts as like a reference.
Yeah.
In order for it to like process it and then give you the appropriate output. It's like input, process, output.
That's actually correct, right? So the machine needs. Oh yeah, please. Can you tell us what data sets are for? Yes.
Is there an example of what the item is helping identify?
Right. So if you give the machine examples of dogs and cats, the machine can identify dogs and cats. It cannot identify a tiger, right? It will probably identify tiger as a cat. But, you get the point, right? They are like examples. So has anybody worked with data sets before? Have you worked with a data set before? Can you give us an example of a data set?
Photos.
Sorry?
Photos.
Photos of,
Five.
for example, which kind of items?
Like a certain hand. Certain hand.
Hand sign. Oh, so what did you do with that data set?
We use a website to identify what hand sign it is.
All right. That's a cool project. So anybody else working with? Yeah, please.
So like we were, I don't know if you would call it base concept, but we basically collected the information of like the length and width of someone's hand, and then we basically just gathered that information, and then eventually we plotted like graph or made like a program where we can predict the length of your hand by only taking the width of it. So it's not really like
How accurate was it?
very accurate. I think it's like around 90 something percent.
Oh, very cool.
Like
Very cool. Right?
It's like a very good approximation.
That's very nice. So you see, you have to collect a lot of data sets to get a machine learning model to perform with a certain level of accuracy. So what Sean is talking about is pretty important first step to building any machine learning model, right? We have to have data in order to train a machine learning model. Can you tell me how many images were you using?
50 for each group.
50 for each group, and how many groups were there?
5.
5 groups. So that's already 250 images. Yeah. And how about you?
We use like around like not like 50 samples or not less, more or less. Like it's not really that much.
It's not that much.
Yeah, like 50.
Right. So depending on the model, the size of the data set that you need also changes. Right? If you have some kind of model that requires less images or less samples in a data set, you require a smaller data set. But some models require huge data sets, right? So before sort of going forward, data sets is an important part. So I think next steps will be to find the correct data set. We'll go through one example and then use that data set, put it on a machine, right, where we'll be training our machine learning model, and then choose a model right? Train the model on that data set, and then will we do inference? No, but the last step of it is inference, right? And even if we don't go through it, we'll have some sort of reference for you to follow along after the workshop, right? So, any questions? Yes. Yeah, understood. Right, so when you sign up to Deployify, it will ask you to also connect your cloud account, right? So actually you need to skip that step because as part of this hackathon, we are providing Microsoft Azure for free on this HKtag 2023 workspace, right? So the account is free to use. You don't need to sign up to any cloud service. We automatically attach our cloud service to this team account. So there was a form which you had to fill out, and then you had to receive an email. Do not fill that form out again. It's crashing our server because we have run out of the quota to send out emails. Right? Just tell me, and I will sign your username up to this team. Right? And then once you are on this team, you will get to use the cloud for free. So you don't need to worry about signing up to any cloud service. Right? For this hackathon, it is free to use. In your own application, right? Do you have one already? Well, you don't have to use this. You don't have to use our cloud service then. If you have something for yourself, maybe I can talk to you personally and then see if we can help you resolve. The idea of this workshop again is to introduce you to the process of how to collect data sets, how to train a machine learning model. What this platform does is it makes it easy, so you don't need to do any of the technical stuff, right? So I can come to you personally and sort of I'll help you answer your questions about integrating your own application. But you can just follow the steps for knowing how to deal with data and how to train. You don't need to definitely use specifically this platform. It's just free to use if you want to use the cloud. So, any other questions? I'll come to you right after. Any other questions? Yeah.
Actually, you this how starting this data and you have to expose it because you use it in your programming data. Actually, I want to clear an air using some data like in the observatory document.
Yeah.
So how can I use the programming or as the platform actually automatically download data and use it?
That's a good question. So sometimes data is not in the CSV or Excel file format. Sometimes it is just an API, and you have to query the API to get the data. Right? So in that scenario, yes, you have to write a small script that can download that data and put it in some kind of CSV format. Right? Because it is real-time data, you need to collect it in order to do any kind of training on that data. Right? So this platform will not provide you any kind of functionality to gather that live data. But once you've downloaded that live data, you can manage it by uploading it to your training server and then training your machine learning. Right? So you still have to write a small script that can download the real-time data if you want to use that. Right? Usually, when you're working on machine learning models, right, the first step is when you're training a model, you need to collect some kind of historic data. right? You need that historic data to be able to train the machine to learn patterns and to do future prediction, right? So maybe real-time data is not so useful for doing training, right? But you may want to use real-time data for doing some kind of predictions, right? Like you want to include that real-time data to do some predictions. For that, you'll have to write a little script for yourself to do that. Does that make sense? All right. Any other questions? All right. So can we continue with data sets then? Everybody knows what data sets are, right? All right. Cool. I'll give it back to Sean.
Okay, thank you. Right, so just as a hypothetical, let's say you do have some files as your data set, as your CSV files, or a bunch of images that you want to use. And let's say you put it inside of this folder, this directory called dataset, and these are the files that you want to kind of use them. So you can follow a few instructions to be able to upload this dataset onto Deployify and to have it appear as something like this. So let's say if I go into dataset 1, which is the new dataset that I've never used, it's empty, right? Okay, I want to upload some of this stuff, okay, onto this dataset. All right, so it's like uploading some files onto Google Drive. Okay, so as a developer tool, we basically made a CLI to be able to do that. Frankly speaking, it would be a little bit better if you could just drag and drop your files and be able to upload them, right? But it's not exactly that simple. So because sometimes when files are too large, like some files could be like, let's say 10 gigabytes, your browser might have a very difficult time handling that, okay? So whereas if you do it through a CLI sort of environment, that kind of file size wouldn't have much of an effect, okay? So, which is why most of this machine learning work still needs to be done through a terminal, through a CLI, something like that. Okay. So now, as a demo, I want to upload some of like these 3 files, okay, onto this new dataset 1 that I've just created. There are a few instructions here that you can follow to be able to do that. So we need to initialize some stuff. We need to basically tell the directory that is the dataset we want to interact with, and then we can push the dataset, which basically uploads the files. Okay. So here's what I'm going to do. So we're going to create sort of a clone directory first. And then create a dataset directory. Let's name it the same dataset 1. And then copy all the files. And then I'll have something like this. And we can move these files to the other side. Okay. So I have, let's say this is your project directory. Okay. I'm just calling it HKtag 2023 clone for now. And then inside of this project directory, you have another directory, refers to folders now, by the way. You have another directory called dataset1, and then you put all of your dataset files into this directory. And you want to upload this whole thing onto our platform. So what you need is the CLI. And all you have to do is to just install it first. For macOS, you do it through Homebrew. For Windows, through Scoop. So once you have that done, we just need to go to Quick Start to basically log in through the CLI. And all you need to do is to just run this command, Deployify login with some generated tokens. So you can generate a personal access token. Okay. And then copy this command and sort of like run it here. Okay. this will only work if you install the CLI already, obviously. So I'm not going to run it because I'm already logged in. And then you don't need to follow this instruction to create a new cloud profile. Just completely ignore this. Okay, we already have, we're already using the Microsoft Azure cloud that we are providing, so you don't need to do any of this. You already have a project as well, so you don't really need to create a new project. Okay, so all you need to do is to just log in. Okay, so once you're logged in, we need to switch our workspace. So again, everyone starts with your own personal workspace, okay? And you should be able to see HKtag 2023 as a team workspace as well. All right, once you join the workspace successfully. So what we can do is we can list the current workspace that we have. Again, it's going to show you the same information, okay? And then switch to the HKtag 2023 workspace, just like that. Okay? If you want to know which workspace that you're working on, you can do deploy file workspace current. All right, it's going to tell you which workspace that you're using right now. There are some other workspace commands here as well. I think you have different commands to do different things on the CLI. Okay, to switch, to list. Basically, the CLI is another way to interact with our platform without doing through the web browser. So once you set it to the HKtag 2023 workspace, we will need to do this one thing. Going back to the instructions, about data sets. Before we can actually run the first command, deploy file dataset init, we actually need to run this deploy file project init. So basically, this deploy file project init is another command that basically helps you connect your project directory on your computer to the project on deploy file. Okay. So, for example, I can do deploy file project list first. I can list all the projects in the workspace, which should be okay. So these are actually all of the projects in the shared workspace. So there's the example team project that I'll be demoing. Okay, so this is the project I want to use. Then all I have to do is to just be inside of your project directory, HKtag 2023 clone, deploy file project init. You just type it out like this, init flag, and then they provide the name of the project, or you can just write deploy file project init, and then just choose the one you want to connect to. Something like that. Okay. So once this is done, it should create a new file on deploy file. It's a settings file. Okay, it tells the project that it's connected to, that they're connected. Okay. So I hope this is not too boring, but the fun part will come later. Now, we want to upload the data set. So what we can do is to, again, now we can follow these instructions. We initialize the data set directory as a data set. Okay, so first step, we initialize, you connect project to project, and then second step, you connect data set to data set. Because sometimes in your one project, you can have multiple data sets. Okay, so for each of those data sets, you need to connect them separately. So we go into the data set 1 directory, and then run deploy file data set init. Again, it's going to allow you to choose which one you want to use, but this is specifically for your project. Okay, so for this, I'm going to use the entry one, and then done with that. Now we can just upload everything to the data set. So deploy file data set push. And it's going to upload those 3 files, and it's going to take like maybe a few minutes or something, depending on how large the file is. So once that is done, I can refresh this page, and then you should be able to see these results. All right. So that's how you put your data set, your files, your data set files onto the cloud, onto Deployify. Okay. And then with this done, you technically can just remove your entire directory like that. It doesn't really matter. It can be gone, and then you can sort of like put it back in. So this basically downloads the data set from the cloud back onto your computer. And you should be able to find it. Yeah. Okay. So now, this is just preparing your data set, right? The fun part is actually the models. Okay, we really want to talk about models. So for model training, you want to do it inside of a training server. So you can create a server, sort of like this. So create a new server, okay, and then name it however you like. Okay, I can name it my server, something like that. And then you can add a data set. So what this means is you can choose the data set that you just prepared, okay, like this one. And then choose a configuration. Now this basically, if you're familiar with machine learning already, you might recognize some of these things, like which version of Python. Who has heard of Python before? Who knows how to write Python? Cool stuff? Yeah? Okay. So for each training server, Python is already installed. You don't need to install it yourself. If you already know machine learning, you might recognize TensorFlow, PyTorch. These are machine learning frameworks. CUDA and Qden, these are NVIDIA software for you to be able to use the GPU for machine learning. And I think for most people, you just have to keep it to default. Okay. If you want to customize your training server, you can choose exactly which version of Python you want to use, or which PyTorch version that you want to use as well. If you want an older version of PyTorch, it's sort of available as well. But I think for most of us, you just keep on. Again, cloud profile, keep it the same as default. And then here's where the interesting part is. Might need to reload the site. Okay. All right. So normally speaking, you should be able to choose a size for your server. I'm going to have to look into this very quickly to see what's wrong. But the idea is that you can choose to use just CPU or a training server that comes with GPU. Okay. I think if you want to start small, if you want to just experiment some simple things, just use the CPU training server, like a small one. It should be good enough. Okay. So. Our platform, frankly speaking, is still a little bit unstable sometimes, so even I don't know what's wrong. But the idea is that you should be able to choose like one of these options and then hit create training server just like that. Okay. I think I'm gonna have to check what's going on with my Microsoft Cloud. This is a problem that's totally unexpected. But the idea is that once you've created a server, okay, you should be able to see something like this. All right, that you have a data set that's mounted, that's connected, and then you'll be able to connect to the server via something called SSH. Okay, so I've created sort of a small GPU server that's running already, and it's connected to the data set I'm going to use. I'm just going to quickly show what that feels like, and then we can start doing some model training stuff. Okay, so to connect to the training server, you can do it through VS Code. Okay, you just have to install an extension, and then you'll be able to play with it. Okay, so if you're already using VS Code, it's going to be very easy. If you don't want to use VS Code, we have a bunch of instructions here that you can follow to manually connect to the training server. It's on a cloud, some data center in the US. And then start using it. So I'm just going to use VS Code here, and I already have the extension installed. Again, the extension is going to ask you to log in. You're going to have to, there are some instructions there that you can use to log in with an API token. But the idea is that you can change to the workspace that we're using, HKtag, and then I can see that there's one server being deployed. Who created this? Did someone create this test server? Yeah, okay. It's still being deployed. It takes usually 5 to 10 minutes to be fully created, and then you can connect to it and start using. But once it has been created, it will show up as a green icon here like that, okay, with the name of the server, and then these are all the projects that are in the workspace. So, just as an FYI, the Wi-Fi that's provided here, VTC Guest, it doesn't really allow SSH connection. So I'm using my own personal hotspot right now to be able to connect to the training server. But if you're using your own house Wi-Fi or any other Wi-Fi, possibly, it should work. Okay, it should be able to do SSH connections. Okay. So to connect to the server, there's an icon here that says Open Remote. So basically, open a remote connection to the server. Okay, cool. So these are, well, this is basically a file explorer. You can see there are a bunch of files here. And the fun thing about this is that you'll be able to see your dataset files immediately in the file explorer. And you'll be able to open them like this, whether CSV data. So this is a bunch of data that I got from HKO, okay, that I've used for the model. And also, within VS Code, you can also create Jupyter notebooks. Who has used Jupyter notebooks before? Anyone? Jupyter notebooks? Anyone has written Python? Yeah, Jupyter notebooks. So Jupyter notebooks is basically the software that we use for machine learning. It's the common thing that we use. So from within VS Code, you can create a Jupyter notebook file, IPy notebook, to be able to do things. So for example, in this notebook, the data that I downloaded from the reference data set from here, okay, it wasn't exactly accurate. Okay, so I wanted to grab the data manually myself through the API. So what I did was I basically hit this URL over and over again to get the temperature data, the humidity data for each day for a total of, well, from 2020 January 1st all the way to 2023 March. So sometimes when you prepare your own data set, you can't just download it. You have to hit an API, you have to call a web request. And in Python, you can write some code to be able to achieve that. Once that is done, you can save it as something called a pandas data frame and save it to a CSV file. Okay. So by running this bunch of stuff, that's how I created this file, weather.csv. Okay? Each line is a API request. Yeah, to be able to get all these values. So now let's talk about processing your data, right? Let's say you're able to upload your data, but sometimes you want to pre-process it. That's what I'm referring to. You need to remove some values that are funny. Sometimes in your data, there are rows of data which just tells you, oh, the data is not available, it's NA. Okay, then you'll have to like remove the whole row, or you need to change NA to a value of 0 or something like that. So pre-processing data is a very important step in machine learning. And what I've done here is to combine the weather data together with the air quality data into basically one file. So particularly, I won't go through the details, all right? But the idea is that I basically took the air quality data only from Mongkok, okay? And then I basically took the weather data as well. So I basically read both files, weather.csv and the air hourly data. Now this one was downloaded from the reference data set directly. I didn't change anything. And then for each of those rows, I basically did some processing. I basically picked out the columns that I wanted to use. So for example, I wanted to use NOx, nitrogen oxides. And for weather data, I wanted these fields, okay, temperature and relative humidity. And by combining these two data sets together, I basically created just one file. And I basically saved it, okay, to this file. I actually able to open it. So, for example, for NOx 39, okay, value of 39, what was the temperature of that day, okay, and also which month was it? So this is like month 1, month 10, and so on and so forth, day and which day, and as well as which hour. So the data pre-processing part is very important. For data that involves time, like date and hour, we use something called one-hot encoding. So this is, I can demonstrate it a little bit actually. So it's a little bit like when you take, let's say, okay, so let's say this is day, month, and year. In machine learning, you can't really just take day and month like that and use it straight up. Why? Because you can have another date that looks like this, 2024, right? How do you say that this is more important, like this date, August 15, is more important than this date? They actually are the same value. It's like you can't, when you compare numbers, it's very easy. You know, 15 is smaller than 23, right? Okay. But in machine learning, in data sets, when you deal with date and time, you can't really say that this date is more important than that date. You can't really say that this date is bigger than that date. You can say it's later than this date, but that's it. Okay. So how we pre-process this data, right, is that we use one-hot encoding. okay, to change this data. So what that means is, you basically say, okay, so for month 1, we create individual columns, month 1, month 2, month 3, something like that, all the way up to month 12, okay? And then we just take this value 2, okay, because we know it's February, so we just write here 1, and then we leave 0 on all the rest. So that's one-hot encoding. It's a very common pre-processing technique for dealing with data or category data. Okay, like you can see, like let's say your column is like this. These are the kind of pets people have. You have like cats, you have like dogs, you have like frogs. Okay, you can't really say cats are more important than dogs. Dogs are more important than cats. Right? So what we do is we change it to one-hot encoding. Cats with 1, dogs with 0, frogs with 0. And then for the second row, you do 0, 1, 0. Then for the third row, you do 0, 0, 1. So this is like one-hot encoding. Now, the data set that you get, usually when you download, each row looks like this. In terms of dates, I can actually show it to you here. Like weather data. It's in this form, right? This is the date. Okay. We can't just use this directly in our machine learning model. We need to transform it. We use one-hot encoding. So month, we basically do 1 to 12. And then day, we do day 1 all the way to day 31. And then we just take. If it's 3, then we just write day 2, day 3, 0, 0, 1, and then the rest are 0. So we have from each of these rows, we kind of need to like convert it into something like this. Very common technique. Okay. So a lot of the times, if you want to do serious machine learning, you kind of have to learn some of these techniques. Hopefully, if you're into the field of data science or computer science, you'll be able to learn this in university, or you'll be able to learn it online from Coursera and stuff like that. There's a guy called Andrew Ng. You might want to Google him. So he teaches AI and machine learning very well. And I think if you're, secondary school or above, you should be able to follow some of this stuff. Yeah, and these are some of the basic techniques that you might go through. So that's kind of what I did in pre-processing the data. Yeah. It's sort of like this line, this magical line is able to change this date into a bunch of this stuff. Yeah, so very often actually in machine learning, if you learn a lot of techniques, you don't really need to write a lot of code. It's usually just like one line like that, and you'll be able to change month, day, and hour, and coding that looks like that. Okay. So please don't get too afraid of writing programs. Once you start to get the hang of it, it gets easier over time. Now, so what does the final data look like? It looks like this. We have knots values, we have maximum temperature, minimum temperature, and all that. Okay, these are inputs. And then you see a lot of 0, 1, 0, 0, 0, 1, a lot of those things. These are the one-hot encoding values, and something like that. So basically, in machine learning, this is what we're going to try to achieve. You basically want to do math. You let the computer do the math, but you design the model in a way that to do that math. So it's a question of transforming, okay, x into y. Okay, it's like a graph. It's like y equals mx plus c. That's actually a model. It's not a machine learning model, but it's still a mathematical model. And all machine learning models are mathematical models, right? So a very simple transformation is something like that. Y equals mx plus c. That's a straight line, right? Okay. Something like that, right?
Okay, you transform x, given a value of x, you'll be able to get a value of y, right? In machine learning, you kind of want to do the same thing as well. X is our input. Okay, our input would be the date plus the time plus the weather. So weather has like maximum temperature, minimum temperature, and all that stuff. Our output is our y. That we're interested is NOx, the amount of nitrogen oxide that you add. Okay, so it's a little bit like magic. Like given this bunch of input, how do we get that output? All right, and we come up with a machine learning model, a mathematical model, a bunch of math equations to transform these values into just this one value. Okay, that's what machine learning is. Actually, I mean, one form of machine learning is to transform input into output. Okay, so once you have all of this data, we actually have like a cheat sheet. We have the x input starting from max temperature, mean gross temperature, and all that. All of this is x, and then our y is here, NOx. Okay, so basically, we're trying to come up with a model that can recognize a pattern between the values of x and the values of y. We're trying to figure out what this m is and what this c is. Okay, so of course, the model is not so simple. It's just one equation like that. It's basically a lot of numbers like this. It could be like y equals to a1x, 1, a2, x2, so on and so forth, plus a and xn. Okay, this is still a relatively easy model, but machine learning is all about something like this. So the way we do that is in code is to use machine learning frameworks. So first of all, you load the data set you want to use to train a model that can recognize the pattern between x and y that we want. The loading part is here. We use something called pandas. I won't go into details. But the key thing that I want to highlight is this. Okay? Now, so in machine learning, you start with a data set, right? Like let's say you have 1,000 images, or you have 1,000 rows, okay, in your CSV file. Usually, the modern approach is to split this into a training data set and a testing data set, okay? And the ratio is usually either 8:2 or 9:1, 80%, 90%, something like that, for training, okay? Now, why this is important is because we use the train part of the data set to learn, to get the model to learn, to get the machine to learn. That's why it's called machine learning. And then we use the test part of the data set to check how good is the machine, how good is the model. Okay. So usually, if you have 1,000 rows, you basically split it into something like 800 to 900, something like that, and then this will be 100 samples. Okay. So what I've done here is that I've split it into 90% training set and 10% testing set. And then we basically just took this one file, process.csv, and just split it into two portions. So this is a very common thing that you want to be aware of in machine learning. Now there's a bunch of code here that basically loads the data into some very useful classes, very useful objects to be used by the framework, and we're using something called PyTorch. Who has heard of PyTorch? Yes? Okay, good. So PyTorch is a very common machine learning framework that you can use to train basically any kind of machine learning model. So for example, who has heard of Llama? Who has heard of LLMs, large language models? Llama, for example, is written in PyTorch, I believe. So, now, again, I'll try to explain a little bit to get you guys interested in machine learning and how it works. Here's what I did. So the model wants to transform transform x into y, right? That's that. Okay. And how we can design this is something like this. So we know that we have a lot of values for x. We have date and time, we have weather data, multiple values, right? So we have an approach called a deep neural network. Okay. Forget about the name, but just try to understand what's going to happen here. So let's say instead of having to deal with a lot of x, we just deal with 4 of them first. Okay. So let's say you have value x1, x2, x3, x4. And then you want to go into 1y, right? Okay. So how a deep neural network works, okay, is this. We can design intermediate layers. And let's say 5 numbers, okay? So we call this values of A, like A1, A2, A3, A4, A5, okay? So what's gonna happen in machine learning in this model is this. You want to transform values of x into each of these values. Okay. And how we do that is that there's a weight value here, like W1, W2, W3, W4, W1. So basically, A1 is equal to W1 times X1. Okay. Is it okay if I go through math? It's okay, right? Okay. Everyone can do math, yeah? So just simple algebra, hopefully. Just simple algebra. So A1 is a value of, is a product of x1 times w1. Okay, x1 can be like some date value or something, okay, or it could be minimum temperature value, all right? And then weight 1 is some fraction, okay, within 0 to 1, all right? And then we basically do the same thing for each of these. These are called neurons, okay? Neurons or nodes. We do the same thing for x2 as well. So x2 will be w, actually this is 1, 1, so w21 times x2, and then w31 times x3, so on and so forth. So basically we have like an intermediate value here. Okay, and we do this for all of the nodes. So you can continue this process. You can create more nodes here. Let's say we have 4 nodes, and we call it D1, D2, D3, D4. And then we do the same thing again. We do multiplication and then division. Okay. So this is how, generally speaking, what modern machine learning sort of looks like. When they talk about neural networks, which is a very common machine learning technique nowadays, this is what is actually happening under the hood. It's a lot of mathematics, but it's actually not too difficult to understand, I hope. So at the end here, y could just simply be the sum of like y equals to b1 plus some weight, multiplied by some weight. Like w1, b1 plus w2, b2, so on and so forth. And then this is our final value. Okay. That's all what this model is like. It's just a bunch of neurons, and they somehow come up with some kind of linear equations, some mathematics, and then you arrive at a final value. Transform x into y. Okay. And when we talk about using the data set, right, we're only adjusting a few things. Okay, mainly this. When we use data sets to train this model, when we talk training, we're just adjusting this value. We're adjusting the weights, W1, W2, and all that stuff. So when we talk about models, is that we have this something called model weights, and this is what we're talking about, model parameters. So when they say ChatGPT has like, oh, it has like 1 trillion parameters, this is what they're talking about. It has like 1 trillion of these weights. So what I've shown here is just maybe like 20 parameters, but the actual model, like for ChatGPT, could be a lot more. Just the training. So going back to what I've actually done, okay, is that I started with something like 12 plus 31 plus 24. So that's month plus day plus hour, and then I go and change the number of nodes to 128,
and then down to 32, and then down to 16. And then for weather, I started with 5 data points, and I go to 20, and then from 20 down to 10, and then 10 back to 5 again. And I can combine date and time together with the weather data to go from 16 plus 5 equals 28, go down to 8, and then add 8 back to 1. So this is our final value here, the final Knox value that we're interested in. We combine a lot of X input into just one Y output, okay? So machine learning code is actually not too difficult to write, because most of the stuff you just use like PyTorch as a library. You just use like linear functions, ReLU functions, these are activation functions. I won't go into details. But the idea is that you basically design how many nodes you want, and then you just start training it with your data set. So the actual training part is that you use the data set to adjust the weights, okay, and arrive at some model that's able to predict the values. So let's say if I run this, okay, so the thing that you want that might be interesting is that if you look at the accuracy, it's something like 40% accurate for the predictions, okay? Not great, it's actually quite bad, but it's something, okay, it's something. It's basically using 90% of the training data set and looking at 10% of the testing data set, and it believes that it's able to perform to 40% accuracy in the testing set, basically. So, this was basically what I was talking about. You use a machine learning model where you create these neural networks, okay, which is a bunch of math behind them, and then you basically adjust the weights as you pass through the data set and arrive at the final value here for Knox. So it's able to reach like 40% accuracy. All of this code that you see here, they are all publicly available. You may feel free to like try it out on your own to try to improve this. You can, for example, change the number of neurons here. You can increase it. Like let's say instead of 128, you can go 256. And then you do something like this. Okay, so you can experiment with this to see if this model performs better than the previous one. So you can add more layers like that to play with it. Go to 16, and then you can do 16 to 16 again. Doesn't really matter. So to be honest, all of these numbers that you see, I just kind of like guess. It's all guesswork. Just try to put in some numbers that kind of make sense and hope that your accuracy improves. That's what data scientists kind of do sometimes. It's a lot of guesswork. Right. So, to improve the model, generally there are 2 ways to do this. You want to use more and better data. Sometimes you can find better quality data. Okay. So for example, the weather data that I have is daily, okay? But the air quality data is hourly. So imagine if I could find weather data that's up to hourly as well. That's a lot more data and probably much more accurate, right? So using better quality data, using more data would generally improve your model performance. Hopefully you can increase from this meh-ish 40%. And the second way is to use more complex models. So this is, for example, I can add more layers, I can add more neurons, like I increase from 128 to 256. Okay, this is one way to do it. Or I can use a different approach, a different model, a different machine learning technique. There are some other neural networks out there that can perhaps fit this use case a little bit better. So the code that you see, including the data set, you can find it from this website. Okay, so if I just try to open it. Okay, so it's an examples repository. Again, this is on GitHub, and the data set is here. The ones that have been processed and the ones that have not been processed, and the Jupyter Notebook files that you can find here as well. I've written some level of documentation to tell you like what are the inputs and what are the outputs. Okay. And if you're okay with learning how to use Python, how to use Jupyter Notebooks, you can kind of like try to run this Jupyter Notebook yourself. Okay, so I think that's pretty much it for the demo part. It's pretty much end of the workshop that I wanted to show. Any questions about the math or the machine learning model or the demo? This one?
Yeah, how to improve the model.
Yes, yes. So all I've done, to be honest, in the last 2 hours doing the demo at least, is to give you a little bit of inspiration as to what machine learning is capable of doing. I use the data set that's provided by the Hackathon organizers, so it's not something totally out in space. Okay, it's down here on Earth. You can find it relatively easily. Okay, so but the point being is that machine learning can do some interesting things, but sometimes even if you try very, very hard, it'll give you meh results, not great. Okay, ideally you want the accuracy to be usually at least 70% to be useful. Okay, that's the bare minimum. Ideally you want it to be at least 85 to 90%. Then that's a pretty good model. Okay, usually in machine learning you can't really hit 100%, and generally speaking, it's actually not a good idea to hit 100%. Why? Because if your testing accuracy is 100%, it doesn't mean that if you put your model out there, it's going to be 100% accurate. No, it would. If you give the model some new data that it hasn't seen before, you try to make a prediction, but it has no idea how accurate that prediction is. Okay, so you can't really say it's 100% accurate.
It depends on how the relations between the
Correct. So using the available data set that we have, we split it into training and testing. At least through the testing portion of the data set, we can tell that it's 40% accurate, or it can go up to 80% accurate, and that's pretty good. Okay, and the model performance is basically all about how good you are at transforming X into Y as accurately as possible. Okay, that's what machine learning is all about. So hopefully that was a good inspiration for you to try out machine learning. I'm not going to force you. We're not here to advocate very hard as to using our platform. Technically, you can write Jupyter Notebooks, you can write Python code straight out of your own computer. You can do this training stuff out of your own computer. You don't really need to use the cloud. This is a relatively small model because it only has like 120, 256 neurons, which is like less than 1,000. So anything less than 1,000 or less than 10,000 or 100,000 scale, that's okay. You can run it on your own computer. But any higher than that, then you're gonna have to start considering using a GPU, using the cloud, using a lot more data, stuff like that. Okay. So this is just a simple model, so you can run it out of your own computer. That's what I'm saying. Any other questions? Yes.
So like all this was uploaded to
So the code that you see here,
yes.
okay, the Jupyter Notebook, all this Python code, it's there here. You can find it in this link.
Oh.
Okay. Which is basically this. Yeah.
The CodeWeave demonstrators at this link. Anybody else who wants this link, please take a picture now. Don't miss this link. We're not going to show it. And then we'll hide it. And then we'll hide it forever and ever. All right? Good. Everybody's got it? We're going to hide it. Hiding it in 3, 2. Let's go for it. 1. All right? Cool. Okay. We can close this. Do we have any other questions quickly? Otherwise, we can move to I think the next session where we are waiting to get some feedback on our existing projects. All right. Cool. Then we'll move ahead. Thank you so much, people, for listening.
I realize that I probably answered a lot. If you feel anyway confused or like just can this guy just leave already? I'm sorry. I'm genuinely am sorry. But this is how we are. Engineers, we're basically people like this. We're not business people, so that's why we kind of talk like this. We like to go into the math if we have the opportunity to. And hopefully that was not too bad for you. Thank you.
好，唔該晒 Lucas 同埋唔該晒阿 Sean。咁今日其實我做咗一個好好嘅 demonstration 俾大家睇嘅。每一條 team 你哋嘅 presentation， 記住你得8分鐘嘅啫。咁同埋加5分鐘嘅 Q&A。咁所以呢啲咁 tag 嘅嘢咧，你喺 behind 度先做 OK 冇問題嘅。你做到 come out 到個result， 跟住然之後你喺8分鐘入邊，你用嗰簡單嘅 presentation present 就得㗎。好冇？所以同埋你今日又好，或者下個禮拜下個禮拜上晝 ESRI 即係 RGIS 嗰啲 tools 咧，你哋學咗，即係我都想你哋學嘅，因為都希望未來對你哋有用。但係學咗之後係咪真係一定要用咧？嗱，唔係必須㗎嚇，唔係必須。你哋覺得你個 proposal 唔需要用呢樣嘢嘅話咧，千祈唔好攞出嚟用，好冇？同埋都係嗰句啦，呢個唔係 business proposal， 你哋唔講你哋嗰個 budget 嘅話咧，唔會扣分。不過你講完之後，你令到你唔夠時間講其他嘢嘅話咧，咁就會扣分啦，好冇？咁同埋講簡單啲講就係PPT 咧，其實簡潔就得㗎啦。你得8分鐘時間 ，assume 你1分鐘，你1分鐘講一張嘅話，或者可能你1分鐘講2、3張嘅話，即係你 maximum 其實你最多只係需要準備16至20張 PPT 嘅啫。咁其實有啲 pain points， 咁我諗 storytelling 係最緊要嘅，所以每一條 team 入邊咧，記住，你一定要有個好叻講嘢嘅人，好識 present 嘅人。咁所以如果你好似頭先阿 Sean 或者 Lucas 咁咧。佢哋就好 tag 嘅，冇問題嘅，即係 tag 都冇問題。但係問題，當你喺8分鐘入邊嗰陣時，你 keep 住講 tag 嘅話咧，咁你個分數有啲難會去攞高分嘅，因為去到最後其實我都係集中想講嗰個你個 solution 點樣幫到件事，咁變咗tag 嗰部分你哋可以behind 佢先收埋，最多就係 Q&A 嗰陣時，如果有人問，有人都相信會有啲 judge 會問。嘅咁你哋到時候答咯，好似今朝話 Alex 佢都有講話，你可以 prepare 定喺你個 Q&A 嗰部分，有人問嘅咁你咪答，好冇？辛苦晒咁多位，今日好啦，咁大家如果關於你嘅 proposal 有問題嘅，咁可以舉手，咁然之後 Sandra 同我咧會行埋你哋個位度，我哋答你哋問題。如果你哋冇問題嘅話咧，或者想留翻下一個問題嘅話，或者想留翻下個禮拜問咧，都 OK 嘅，好冇？咁知道我一定會嚟呢度先嘅，係啦。咁如果有問題嘅隊可以留低喺度，咁我哋大約應該5點半到5點9我哋但係都要完場，咁所以即係你要離開㗎。咁所以大家好冇？有問題嘅話可以留低問。如果冇嘅話，咁今日辛苦晒咁多位，咁我哋下個星期6上晝9點半見。記住盡可能帶到 Windows 嘅 notebook 同埋記住帶個 mouse 嚟。好嘛？知道張台唔係好大㗎，辛苦晒。咁但係盡量啦，好冇？唔該晒 ，thank you。